notebooks in a Claude code world. I want to thank the organizers for putting together such a nice conference and meeting everyone out here. The community is always great at Pydata conferences, so thank you. Thanks for sticking through to the last talk here. So I'm going to get really quickly into a demo of what we're going to be talking about, and then I'll explain the reasoning why I built it the way I did. So this is how I want to interact with Claude Code and Jupyter Notebooks at the same time, or a Jupyter Notebook-like environment. So I'm going to jump right into it. This is a sample catalog of data where I have 3 expressions. I have Apple, open, high, low, close, and stock data. We can scroll through it. We can see histogram of open, high, low, close. We can go over and see summary stats. Here's city bike data. This isn't, sorry, it's an American New York thing, but it makes sense for the next piece I'm going to do. So here we have, I think it's a year's worth of trips. So 2.5 million rows. We can scroll, let me just get the scroll handle. We can scroll anywhere in here and see the data. We can sort by started at. This is how I want to look at data, and I want to be able to see the data. I don't want to see like a little table, I want to see the data. So here is route distance, which is an aggregation on that city bike data. And this is city bike routes grouped by start and end station with the haver sign, which is a fancy way of saying as the bird flies distance between station. Average speed, minimum 50 trips, and excluding same station round trips. So let me come over to Claude, and we're going to update this. Oh, I'll just copy this. Okay. Claude is generating code for this, and it's going to be put in the app. And I'm going to go through how all of it is working. That was pretty quick. Humor me and do it again. I reverted this just before the start of this. And if this doesn't work, I know I have it pre-cached. This does work, it has worked. This is also doing a live demo. But this is an interactive tool, and we should be doing live demos. OK, there we go. Version 3. That is not showing up. This is basically the same thing. So what I did was replace the haversign distance with Manhattan taxi cab. So if you go up an avenue and over, and it's rotated to the angle that Manhattan is, because that's closer to the distances that bikes will actually have to go. And we can see the grouping here. So we can see the route kilometers, average speed in kilometers an hour, and which station it starts and stops from. We can also see a diff. And it is computing a diff. And now we can see the magnitude of change. So this, let me come over to the detailed percentage view, and I'm going to sort this by detailed percentage. So what this is telling me is from West 8th Avenue and 33rd to East 33rd and 5th Avenue really changed very little. So I'm hovering over, and there it's 0.85, and previously it was 0.87. If we scroll down a lot, we get much larger differences. So we have 1.6 to 1.3. Come back to the catalog and come back to the London demo. So let me talk a bit about, this is the app we're generally going to be talking about. Let me go through why I built it this way. So I'm Paddy Mullen, Paddy at paddymullen.com. You can find me on LinkedIn. I love notebooks, and there's a lot of good things about notebooks that I still want in a Claude code world, but it's difficult to interact with. So let me go through the things I love about notebooks. They're interactive. You're meant to write code and interact with a running Python process. That's really cool and really powerful. It's probably the most used literate programming environment where you can combine explanatory text with code and outputs. And you have a rich multimedia environment. You have images, rendered markdown text, and interactive widgets. And then there are real graphical widgets that can be integrated with very little Python code. And I don't know how many people have seen IPy widgets, but they're really cool. Wait, who here uses Jupyter? I forgot. Okay. Who here uses pandas? Polars? And then who uses Claude Code? Who has used Claude with Jupyter notebooks? Okay. There are problems with notebooks, though, and people have talked about these for a long time. The notebook depends on a running Python kernel to act as an ad hoc cache of expensive operations. The kernel is interacted with via cells, and state can be introduced in one cell, depended upon by others, and then the first cell can be deleted. And you can just do that to yourself without anyone else interacting with it. This prompts you to write your own ad hoc caching techniques, which could be as simple as don't re-execute this cell, or maybe you save something to disk temporarily, and then you do other things. Most tooling is set up for curated presentation, not fast exploratory analysis. And it's difficult to interact with notebook kernels from multiple users or with agents. People are trying to address this. Every notebook has some type of LLM integration, like a little chat, and like it will write some code for you. Marimo makes notebooks a DAG and throws loud errors if the dependencies are broken for the cell dependency problem. Kyle Kelly is working on multi-user and single-user plus LLM interaction via CRDTs and Interact. He's doing some really cool stuff. I built Buckaroo to solve a lot of the interactive use cases. So let me introduce Buckaroo to you. I've spent the past 3 years working off and on Buckaroo. This is the table widget that I've wanted in Jupyter Notebooks for a decade. The most basic step of data analysis is looking at the data. When I was a quant dev at a hedge fund, one of the really key memories I have was I was reviewing a model with a trader, and we were rewriting it from R into Python, and we weren't getting the right output. So I was saying to him, well, look, we start here, we do this transform, we do that transform, and then we do this other stuff, and which transform do you think is wrong? And he said, what does the data look like? I'm like, but we have this transform. And he said, but what does the data look like? Look at the data. When you work with tools that make it hard to look at the data, you don't do that. And we should work with tools that let us look at the data. So this is like standard pandas. We're going to read a CSV. Pandas is a great library, but it's not a presentation library. And you see the first 5 rows and the last 5 rows. We can call df.describe and see summary stats. We can call df.sortValues by trip duration, and we can get that. I know how to type these commands. I've typed them many times. I don't want to have to type them every time because that's slow. So I built Buckaroo. Buckaroo, when you import it, becomes the default display method for tables in Jupyter. We can sort. We can search. Barclay, we can look at summary stats. Oh, and when we search for Barclay, we can see that we've gone from 100,000 down to 812 rows. These are things you're going to want to do with every data frame. You don't have to type Python code, and you don't have to wait for an LLM to type Python code that you got really lazy with, and you don't want to type it anymore. So exploratory data analysis in the Claude code world. Claude is great at writing Python code. It knows pandas, polars, it writes Jupyter notebooks, it will write little snippets. So are we done? Like we don't have to do like Jupyter type stuff to look at data anymore? Not so fast. We still need to review the results and we see where we go next with our analysis. We're still doing exploratory data analysis. And exploratory data analysis isn't just looking at, I have this new piece of data, let me look at it and make sense of it. Every time you do a transform, you're doing some type of exploratory data analysis. Did I get the result from that transform that I wanted to? Whether you wrote the transform or Claude wrote the transform for you. I want to do that in a serious table, not a TUI table connected to an LLM that makes my childhood 1200 baud modem look fast. Like, let's use a real table. Claude and any standalone LLM does a poor job of interacting with Jupyter. It's having two people work on the same Jupyter notebook, you're going to run into trouble. Having Claude send commands to a Jupyter notebook, you basically have to re-execute your entire notebook each time Claude touches it, which, like, that's slow. And it's annoying. So we should just let Claude be Claude. The other thing, and this gets to some other points, but Claude sessions are like shell history. In theory, like if you save the complete transcript of your shell history, that would be useful. You could see, well, I went over here and here's what I did here. But we don't actually look at our shell history. We throw it out because it's a mess. You like cd into a directory, then you cd into the next directory, you ls, then you ls with some special arguments that you've looked up, and you just throw it away. Jupyter Notebooks change that because you are iterating on an idea in each cell. And you will type ls in the cell, then you will type ls with the command line arguments you want, and you are refining that concept there. And has everyone seen like the cell overriding and that? Okay, so I don't have to go through that. Data pipelines we can trust and reason about. We write Jupyter code in Notebook and we worry that it reproduces. Can someone else execute the same cells and get the same results at the end? That's important, and UV helps a lot. But that's hoping for an end result. And the reason we need to run the whole notebook is because it's squishy. What if instead we said, how can I have more confidence in the result of a computation before performing it? What would it take me to trust a cache so I don't have to re-execute it each time or keep the whole results in memory? So you could write import pandas, you read some CSVs, you output to a Parquet file, and sure, what if one of the underlying files changes? You could write like a little helper for this, but output.parquet, maybe someone else wrote to that. You have no provenance. And that helps, but it's a hack. So let me talk about Zork for a bit. Zork is a library built on top of IBIS. IBIS allows you to have data frame-like syntax that connects to multiple backends. Databricks, Snowflake, Postgres, Pandas, and Polars, depending on which version of IBIS. Zork lets you form a whole compute graph, and then you can reason about it. So in this example, we're reading the same 3 CSV files, but we're having this like little line where you say Parquet cache. And from here on, we can reference that expression, but if one of those files changes, Zork checks for us behind the scenes and says, has that changed? Okay, if that's changed, I need to recompute the whole thing. This lets us reason about this expression without executing it, the whole thing. And that's a lot of what this notebook-like experience is built on. When curated for a presentation, a notebook will generally follow the pattern of markdown cell, which tells you why, Python code, which tells you how, and output, which tells you what you did. The notebook cell format is already a huge improvement over shell history. We back into why when we present. So like, you'll have a notebook, and you'll just like type a bunch of stuff, you're looking at things, and then, okay, I have my own thesis. Let me go and see which pieces of little analysis I'm going to chuck out, and then you write your markdown cells, for the most part. Like maybe you comment a little, but yeah. Intent matters, and most tooling built with LLM throws it away. We get our why cells for free from the prompt you ask the LLM to write code for you. And if you save that, that's the start of your markdown. So you never have to wonder, like that little bit of ad hoc analysis, what was I doing there? You're not just looking at code and trying to figure out what you were thinking. You know what you were thinking. So we can combine this all into the demo that I showed. And this doesn't replace notebooks. Like this is, in my view, like I'm really only using notebooks when I'm looking at large amounts of tabular data. I'm not doing little bits of Python code here and there. Like it's cool to use a notebook and experiment with that, but that's not what no kernel notebooks, or as I named it this morning, Tallyman, is useful for. So how does this work? Let me scroll down to the bottom and we can see, no, we can't. Bah. I had a nice, oh, there we go. I do have a nice diagram. Okay, so Claude Code talks to an MCP server, which talks to the catalog server. It notifies the catalog server, and it writes expressions which are put into a catalog. The MCP server also notifies a Buckaroo server. Your browser is connected to the catalog server and Buckaroo server. So basically, Claude is just writing little bits of Python code that write these Zork expressions like I showed in that example. And then you're managing it with another system. Are people following? Have I lost? Okay. So that is this system that I built. And what did I want to show you here? So with certain data frame libraries, polars in particular, Buckaroo can work lazily. So here we're looking at 2.5 million rows, and this is not all loaded into memory. There's a series of computations, and there's a Parquet file for cache. But when I scroll here, that little flash of none and then it loads, that is JavaScript in the front end calling to the Buckaroo server and saying, give me these 50 rows. And that's all that's sent. So we're memory efficient, and we don't need to worry about having the whole thing in memory, because we can tell what our computation graph coming up to this is. The same with search. So we're searching over 2.5 million rows, and now we're down to 335,000 filtered. There are histograms, and like there are two types of histograms here. These are categorical histograms. So I'm taking this space, I want to use it. So they're like, here's your regular numerical histogram, but then you have categorical data. So like, is the member casual, or like, they just sign up for that day or there? And we can tell that this row only has 2 values in it. A little bit about styling. This Buckaroo table does not look like most web apps we see. And I think there are kind of 2 types of styling in the world. We have venture capital styling, where you're going to have a table with nice rounded corners and padding and lots of space, and you're only ever going to show a table with 3 columns with your freemium, your mid-tier, and your enterprise call us. And then there is trader styling, and a trader will jam every bit of information into every pixel on the screen. This respects your screen real estate. TUIs are really popular now, and I don't know why, because it's a distinctly less powerful than a GUI. But I think that in TUIs, people are like, oh, I don't need to put all this padding. I can actually get more information onto the same screen real estate that I normally would. But you can just reduce padding. You can do this. You should do this for your apps. So, oh, right, let me show that. Coming back to Claude, make an expression called, oh, we already have prices. Nope, not that bit. Add a post-processing function. Okay, add a post-processing function called daily returns that per ticker computes the day-over-day percentage return of the close. Keep date and ticker, drop the raw OHLC columns. So right now, Claude is writing some code, and it's being put in the app. Okay, let's see. Can we see this? We can. It will work over here. So we've a post-processing function is something that's built into Buckaroo, and it goes from data frame to data frame. And then you can apply a bunch of them. So we're dealing with a static set of objects here. It's not like Jupyter where you can just type some random Python code. And you still need to do ad hoc analysis on these data frames you're going to see. This is the way I'm enabling that in the system. And the nice thing is we can reuse these. And it's not in there right now, but it will very soon be coming. Oh, right, I haven't shown you all that. It doesn't matter, they're basically the same. We can also see the code for all of this. So here's the code for the Manhattan distance. Go over to V1 code. You can see that code. I've not read this closely, but we can see it. Post-processing functions, I don't have a current way you can view that in the UI, the code there. But this lets you verify, hey, here's this little utility I wrote. Let me verify it, and then I can reuse it. And I can reuse it on all these other data frames that are similar. And I can trust that. Building stuff in this way, where you use the LLM to do something ad hoc, and then you put it into a concrete workflow, is much better than just asking the LLM each time, hey, can you calculate daily returns for me? Because the LLM is going to give you a slightly different answer each time. You want to be able to trust, like use it to write code for you, but then verify that code and trust it. And use systems that let you trust it. We also have a notebook view where these are the prompts that I originally put in. And we can edit this, and we can just put in a title here. Title I wrote. Cool. OK, renders as a title I wrote. There is an export to Marimo button. There will soon be an export to Jupyter Notebook. So you can take this list of expressions you've done and curate them. Sorry. Another piece. We've named these expressions. So remember how I was saying in a Jupyter Notebook, like you keep working on the same cell. That's why you don't have like all this shell history trying to get the same thing. When we updated route, it became route v2. And you're saying, this is my concept for route distance. And if I want to build something else on that, I'm going back to the same named concept. All of this is in Git also. And basically just the expressions, not the data. The data stays in a cache outside of Git. So let me read. Okay. OK, so tallyman revisions. Nope. We can see each modification I made to that notebook. And then we can reset to a previous revision. And it works. I don't want to do it right now, but it does work. And those are very lightweight commits because there's not data there. I'm not snapshotting the whole world or an entire kernel state. Oh, naming. So Buckaroo is my table widget. And I named that because it helps you wrangle data. I came up with tallyman this morning / last night. And tallyman counts the cattle as they come in from a roundup. And tallyman lets you count what your LLM is doing and keep track of it. So there are a couple of interesting things building with LLMs and building in an LLM world. I'm so used to, as a developer, thinking of, oh, compute is expensive. I need to cache that. I shouldn't do that, or I should be careful about it. We're spending a lot of money on Claude, and it's doing a lot of stuff in GPUs. It's really expensive compute. So our whole compute budget for what type of apps we want to build has just gone up massively. The transforms you want to do on tabular data are cheap compared to whatever you're doing on a GPU. So do more of them. Like you can optimistically, there's a different word I wanted to use, do summary stats. And if they're never looked at, that's fine, because it is so cheap to do that compared to one response. And it's cheap from a monetary, and it's cheap from your attention. Like, when I use Haiku, I get results back in 5 to 10 seconds on a good day. I don't want to wait for that. Like, I don't want to wait to ask Haiku to sort something. I don't even want to wait for it to cat a table and output it, because that's what we should be looking at this stuff. We need tools that make it easy to output validate LLM output, so we actually validate the output. Like, if you're not looking at it, you don't have tools that make it easy to look at, you're not going to look at your data. We should use non-deterministic LLMs to build functions that you can reuse. Validate the functions, then apply them broadly. And most importantly, more trusted, and they're also faster and cheaper. LLM agents are a really exciting time for programming. It's easy to write libraries, and it's easy to get LLMs to use them. So you can write a library with a new syntax, and you don't have to convince everyone to, like, your syntax is great, and you should learn my syntax. You just need to convince them that their LLM can do that, and make sure your LLM can actually use it. And that's a much easier space to be in. So we can try new things, and people are doing different UI paradigms. They're in the terminal. They're using Claude Cowork. Get in touch, Paddy at paddymullen.com, and here is the Tallyman repo. Thank you.